Okay, 8th graders. This is your guys' math lessons for the week. Hopefully, I can get these all done before you guys actually show up. So, to start off with, you will need your book, work paper, something to write with, don't really care what. I'm going to use a pen so that you guys can see it easier. You guys are welcome to use um, whatever you want. First off, we have some vocabulary. Yesterday I put some of these on the board. We're going to add these last a few that we didn't get before. So first off, we have transversal. It's just a line that intersects two or more other lines. If we have one line here and one line here, these two lines are going about their business, going off and doing their own thing, and then we run it through with another line. This line that intersects them is the transversal. That is our transversal line. It makes a bunch of angles here. We've got an angle here, 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 and here, and angles here, 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 and here. We're going to be studying how those angles interact with each other in this unit. First up, we have the interior angles. These are the angles inside the lines. So, we've got our line, two lines that are just going about their business. We have our transversal line. And then we have these angles 4, 3, 5, and 6. Those are your interior angles because they're inside the other lines. Next, we have our exterior angles. And these are the angles outside the lines. So again, we have our two lines going about their business. Transversal line coming charging through. And then we have angles 1, 2, 8, and 7. Those are our exterior angles. Now for our relationships, we have our alternative interior angles. And these are, we again have our two lines sitting there doing their thing. Transversal line comes charging through. So our alternate interior angles are the ones that are across from each other. So 4 and 6. And these angles are the same. 4 and 6 are equal. So 4 and 6 are equal. And 5 and 3 are equal. Just because they are alternate interior angles in one way or the other. Then we have our alternate exterior angles. These are two normal lines. Transversal comes through. So these are alternate exterior angles. These are 1 and 7. So 1 equals 7, and 8 and 2. Those are our alternate exterior angles, and they are equal in that way. Then we have our corresponding angles. Our corresponding angles are angles that are kind of in the same place as each other. So 1 and 5. And these ones are also equal. 1 equals 5, and then 2 and 6. Also, 4 and 8, and 3 and 7. But I don't want to fill it in because I don't have enough space. Which means that in total, 1, 5, 7, and 3 are all the same. 1 equals 3 equals 5 equals 7. And 2, 4, 8, and 6 are the same. 2, 4, 6, and 8 are all the same. Okay. Next things, special kind of intersections between lines is we have perpendicular lines. We have perpendicular lines. These are lines that hit each other at a 90-degree angle. They intersect. That's a big word for hit. At 90 degrees. And you'll see them with this little kind of square box thing. Whenever you see that little square box thing, that means that that angle is equal to 90 degrees and that this is a perpendicular intersection. Next kind of special case is lines that never intersect. These are parallel. These are lines that never touch. So we have a line going along and another line going along. And you'll oftentimes see a little thing like that. A little colored in triangle shape between two lines. And that means that those lines are parallel. So those little guys mean parallel. You might also see just a symbol of just like that, and that can mean parallel too. Okay, I think that's enough vocabulary. Moving on to our actual thing, we have parallel lines. Symbol for it, they're using the just two straight lines, perpendicular line. They're using the symbol of that. They aren't putting the square on it. They don't have to, and they aren't putting the little arrows on it. They don't have to. Define in our own words. Well, for me, lines straight, no touching. And then for perpendicular lines, two lines, straight, and hit 90 degrees. Draw it, well, and then I like to use the little thing to show, but you don't have to. Two lines intersecting at 90 degrees, and I'll put the little thingy in there to show it's 90. Real world example of it for parallel tire tracks. They'll go forever. They will never intersect. And then for perpendicular, a bird diving straight into the water. You can use your own examples if you want. These are just examples. Moving along. Over to here. We have transversals and angles. A line that intersects two or more lines is called a transversal, and 8 angles are formed. 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7, 8. We have our lines L, I, and K, with L being the transversal. Interior angles lie inside the lines, and they have 3, 4, 5, and 6. Exterior angles lie outside the lines, 1, 2, 7, and 8. Alternate interior angles are interior angles that lie on opposite sides of the transversal. When the lines are parallel, their measure are equal. So 4 and 6, 2 and 5. Alternate exterior angles are exterior angles that lie on opposite sides of the transversal. When the lines are parallel, their measures are equal. So 1 and 7, 8 and 2. Corresponding angles are those angles that are in the same position on the two lines in relation to the transversal. When the lines are parallel, their measures are equal. 1 and 5, 2 and 6, 8 and 4, 7 and 3. Special notation is used to indicate perpendicular and parallel lines. That's where we see the little thing that I like to do and the little arrows that I like to do. And they can also be shown as just that. And these little letters tell us that it's line M and line N that are perpendicular. So anytime you see this symbol or that symbol, it means that they are perpendicular or parallel. Okay, classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. We have 1 and 7. 1 and 7 are both exterior angles because they're outside of the lines, and they lie on opposite sides of the transversal. So these are alternate exterior. They are alternate exterior. 2 and 6. 2 and 6. These are 2 is an exterior angle, 6 is an interior angle, but they're on the same sides of the transversal and they're in the same position. Kind of top right hand side in both cases. So these are corresponding angles. Now let's move over and check number A. Classify the relationship between 4 and 6. So we're going between 4 and 6. They're both interior, so they're both inside. So these are, we know that they're interior. And they are on opposite sides of the transversal. We have to go across from this side. We have to go from here to here. So that is alternate interior. So these are alt, int, and you can use abbreviations. This is math class. Now, finding the missing angle measure. To do this, you need to know something. Angle 1 plus 2 equals 180. Angles 4 plus 3 equals 180. Angles 1 plus 2 plus 3 plus 4 equals 360. And the same goes true for any corresponding angles or alternate interior angles that you can use to get to your answer. So, yeah. If we're trying to, when you have two parallel lines that are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measure of all of the angles. Suppose you know that M1 equals 50 degrees. So this one, M1 equals 50 degrees. You can use that measure to find the measure of angles 2, 3, and 4. So we know that 50 plus 2 has to equal 180. These are called supplementary angles. 1 and 2 are supplementary. And you don't have to write supplementary there. But 50, 50 plus angle 2 equals 180. We subtract the 50 from both sides, minus 50 minus 50, and that gives us angle 2 equals 130. Good morning. Now that we have angle 1 equals 50 and angle 2 equals 130 degrees, we can use the relationships to figure out the rest of them. So 1 and 3 has to be the same because they are opposite angles. So 1 and 3 are, means that 3 is 50 degrees, and 2 and 4 have to be the same because 2 and 4 are both 130 degrees. Um, so, and we can tell that by looking at 1 and 4 also add up to 180. So 1 plus 4 equal 180, and so does 2 and 3. Angle 2 plus angle 3 equals 180. Just because all the angles that go along, so you have a straight line, and that line has things coming off of it, all these angles put together have to equal 180. So if this is A, B, C, and D, then A plus B plus C to plus D has to equal 180. Any combination of angles that adds up to a straight line gets you 180 degrees. So 1 plus 4 gets you to a straight line, 2 plus 3 gets you to a straight line, 4 plus 3 gets you to a straight line, and 1 plus 2 gets you to a straight line. So those ones all have to add up to 180. Example, a furniture designer built this bookcase shown. Line A is parallel to line B. So A and B are parallel. If M2 equals 105 degrees, so 2 equals 105, find angle 6 and angle 3. So we know that 2 equals 105, and we know that 2 plus 6. So we know 2 plus 6 equals 180, or angle 2 plus angle 6. And we know that angle 2 equals 105 plus angle 6 equals 180. So we subtract 105 from both sides, minus 105 minus 105 equals angle 6 is 75 degrees. So now we know this one is 75 degrees. And since angle 6 and angle 3 are alternate interior angles, where they are on opposite sides of this transversal, we know that they are the same. We know that angle 6 equals angle 3 because they are alt int. So that means that 3 equals 75 degrees. Now we have to find angle 4. So we could use, to find angle 4, we could say 2 and 4 is complementary, that these are complementary angles because they're in the same spot. 2 and 4 are in the same spot, so we know that 4 has to be 105. Or we could say that we know that 3 plus 4 equals 180, therefore 4 has to equal 105. So either say 105 equals angle 4, and then use corresponding angles, or you can say that 3 and 4 are supplementary angles. Okay, example 4. In the figure, line M, this one, is parallel to line N. Line Q is perpendicular to line P. Now we have that little red square down there. What is the measure of 1, or the measure of 1 equals 40 degrees. 1 equals 40 degrees. What is the measure of angle 7 over here? So, we know that 1 plus angle 10 equal 180 because they're supplementary. And we know that we know 1 angle 1 plus angle 10 equal 180. We know that 1 equals 40. Whoops, sorry, dyslexic. 180. And we know that 1 equals 40, so we know that 40 plus angle 10 equal 180. Subtract 40 from both sides. And we know that angle 10 equals 140. Now, so that gives us angle 10 is 140. Now we also know that since angle 10 is the corresponding angle to angle 7 plus 8, so angle 10 equals angle 7 plus angle 8. And we know that 10 is 140. So we know that 10 is 140 degrees, and that equals angle 7 plus angle 8. But we also know that angle 8 is equal to 90 degrees because they give us that. So 140 degrees equals angle 7 plus 90 degrees. We subtract the 90 from both sides, and we are left with 140 minus 90, which is 50 degrees, equals angle number 7. And so 7 equals 50 degrees. Now, the book is solving in a slightly different way. They are saying that since 1 and 6 are alternate exterior angles, that 6 is equal to 40, and that is true. And that's then 6, 7, and 8 form a straight line. The sum of their measures is 180, because any set of angles that adds up to a straight line equals 180. And that we know that angle 8 is 90 degrees, so then they substitute 40 for 6, 90 for 8. Angle 7 is the one we don't know, equals 180. So then they subtract 40, they subtract 90 from 180, and that gives them angle 7 of 50. That is a slightly more complex problem, but by no means not unsolvable for you guys. Okay, guided practice. 1. Refer to the porch stairs shown. Line M is parallel to line N, and M is and angle M7 is 35 degrees. So 7 equals 35 degrees. Find the measure of angle 1. Okay, so 7 is equal to 6, 2, and 3, because these are, corresponding angles, alternate exterior angles, or an alternate interior angle to that one, and I forget what it's called when they're straight across from each other. Shoot. Vertical. So 6 and 7 are vertical, so those are the same. So 6 is equal to 35, 3 is equal to 35, 2 is equal to 35. So these are 35, 35, 35. So to find angle 1 now, we can say that, angle 1 has to, angle 1 plus 2 has to equal 180. We can say that angle 1 plus 3 has to equal 180. We can say that 1 and 4 and 5 and 8 are all the same, and then we can solve for 8 and say that 8 plus 7 has to equal 180, whichever option we want to do. I'm going to do angle 1 plus angle 2 equals 180. Then, since I know that angle 2 is 35, plus angle 1 equals 180. I can subtract 35 from both sides, and that is 145, I believe, but check my math because I'm not always the best at doing it in my head. And so that means that angle 1 equals 145. Angle 1 equals 145 degrees. Because angles 7 and 2, angles 7 and 2 are equal by alternate exterior, alt x, and then angles 1 plus 2 equal 180 by, because they're supplementary angles, I believe is what it's called. Yep, supplementary. Revert to the figure on the right. Line A is parallel to line B, so A is parallel to B, and angle M2, that one, equals 135. Find each given angle. Justify your answer. Okay, so 2 equals 135. and then angle 9. So 2 equals 135. 9 and 10 are together vertical angles. So angle 2 is equal to angles 9 plus 10 because of vertical angles. And if 2 equals 135, angle 9 plus 10 we're given is equal to 90. 135 minus 90, which is 45, but check me on that because I'm not always the best at math, equals angle number 9. 45 degrees, angle number 9, because of vertical angles. So angle number 9 equals 45 degrees. And I got that because these two, 8 is a straight line, A is a straight line. So if it wasn't for this E line that was coming off that's perpendicular, we'd just say that angle 9 is equal to 135 because it is the vertical angle to number 2. But since we do have this angle number 10 that is taking up some of that, we have to subtract that out. Because angle 9 plus angle 10 are vertical to angle 2, and angle 10 equals 90 degrees. Now to find angle 7. Well, angle 7 and angle 2 are pretty easy because they are alternate interior. So we can just say that angle 7 equals 135 by alt int. Building on the essential questions, how are the measures of the angles related when parallel lines are cut by a transversal? They either add to 180 or are equal. Oh shoot, I should put, let's see, this is number, this is number 1, this is number 2, yeah, sorry, I should make better care to make certain I'm showing my work and that you can see where I'm doing my work. Okay, moving on. You guys, with your independent practice, I want you guys to do the odds. So 1, 3, 5, 7, A and B. 9, 11. Don't worry about doing the extra practice. You guys are going to have plenty of extra practice this week because we're moving on to lesson 2. Okay, Lesson 2, geometric proof. We have a bunch of vocabulary again. Inductive reasoning. You know what? I'm going to finish this lesson for you guys later because you guys are almost here.